Good afternoon, everybody. I think it is time to start. My name is Bill Fortney. I have the privilege of leading NC State's engineering program here in Havelock, and it is great to see everybody. If you've been here before, you know this is kind of a family affair time. So we enjoy the time. One thing I need to say, we are recording today, so the students have it. So if you don't want to be in a recording, please let me know afterwards, and I will make sure you're not, or we don't show any pictures of the audience. So please let me know that. So let me ask a couple questions. First, who is here connected with NavAir? If you'll raise your hand. Quite a few people. Great. Who is here representing community, either formally working now or has in the past serving in our community? I was going to say, I know Chris is. Tom, I would say that probably depends on you. How about Craven Community College? Gotcha. Quite a few people. Okay. Anybody else that has been involved with the program here? Did I miss anybody? Okay. Yep. Got quite a few other people. So I got to thinking that this summer marks the 20-year anniversary of NC State's work here in Havelock. And it's not NC State's work, as we all know that have been involved. It is a community work. And so the things that have happened are the things that we as a community are celebrating. And so I got to thinking it might be fun to realize that some of these people, this is not the first time that they have worked together on a team. In fact, let's see what we got here. Yeah. So there's Andrew and Bethany. You're going to see them. So look at that. They're sitting together right now. How about that? And not to try to cause any trouble, but in case the picture isn't clear, there is a second place here and a third place right here. I'm not sure what that means. So that is Andrew and Bethany in 2015 at our engineering camp that we did here. And then we can't leave Nicholas out. So where's Nicholas? Nicholas was there. Yep, there's Nicholas the last year. And then I threw these two up because I thought these were pretty fun too. So the top one, 2007, that's Michaela Rickard, who is now Dr. Rickard, who works with the CDC, and she is doing research in overdose prevention. So doing some pretty neat stuff, continuing to serve. And then on the bottom is Sophia. And Sophia was just announced that she's an NC State Park Scholar who will be starting up in Raleigh in aerospace engineering. So, you know, the work that we together have done continues to pay off. And that's what we're going to see today. You're going to hear from a few individuals. It's representing the work of 10 truly amazing young men and women. The work that they have done is great. It has been a privilege serving with them, being a small piece of their story. And I'm excited to be able to hear them today. So with that, was that short enough, Savannah? See, Savannah keeps us all in line. So she said, so how long is your introduction going to be? So I said, 4 minutes. So I think I was close to that. So with that, I'm going to turn it over to you.
Thank you, Dr. Fortney. Well, hello, everyone. Good afternoon. My name is Savannah Tabor, and I am a senior here at the MES program underneath North Carolina State University. And we are so thrilled that you all have came out today and came to support us and allow us to present to you our final solution of our senior capstone design project. I'd like to invite my classmates up just so we can introduce everyone. All right, well, I'll let you start.
I'm William Anderson. Gavin Earhart. Matt Willis. Andrew Padgett. Nicholas Connor. Dan Earhart. Luke Clark.
Bethany Lear.
Eric Meredith.
All right, and now that you have met everybody who has had their hands in this project, I'll let them take a seat and I'll provide everyone with an agenda and jump right into the presentation. So today, your agenda is also available in your pamphlet on the table as well. We're just going to provide you with some background and sort of catch you up and fill you in on this project and what we were initially given by some engineers on the Fleet Readiness Center East at Cherry Point. And with that, we will go through how we evaluated that initial problem from Cherry Point, and we will be presenting to you our 2 design solutions and how those design solutions evolved and developed through the conceptual, preliminary, and final design stages. If you have any questions or comments, we'll have time at the end to hold an open conversation about that. So jumping in, pictured here is the CH-53K helicopter, which is used by the Marines. And over at FRC East, they have a fleet support team known as the FST, and they support this aircraft and its Marines to keep it up in the air and supporting the mission. Essentially, the engineers from the FST came to us and briefed us with an initial problem, and that was that they had identified a need for a storage solution for a component that comes off of this helicopter. Some more background for you. This is an internal view of that 53K and its drive system. Circled in the middle is the main gearbox, and it transmits engine power and torque to several of the subsystems that you see here. And here is a bigger picture of that for you. Sikorsky, who is the original manufacturer of this aircraft, designed this gearbox to be a modular design. With that being said, you can individually disassemble and replace components as necessary. One of those components that can come off individually is known as the rear module assembly, and today you will hear that called the RMA. And that is the component that the FST reached out to us about creating a storage solution for. So I just gave you a crash course of what we were given by the FST. And upon receiving that information, we began to step through the engineering design process that we've been learning here at the MES program. So we stepped through evaluating the problem, setting some requirements, and moved on to conceptual design, moving on to preliminary design, and arrived at our critical design review where we received engineering approval on our final design. And that final design is what you will be seeing here today. So with that, I'm going to turn it over to Thane, and he's going to finish providing you with details of how we step through this engineering design process.
Thanks, Savannah. So problem evaluation in engineering is one of the most important parts of the solution process, because if we don't correctly understand a problem, then we're not going to have the most effective solution. So what we try to do here and what we're taught to do here in Havelock is to understand the problem and understand what the problem really is before we jump into the how to solve it. So in effort to do that, we were able to visit a squadron down in New River, and we were able to get a look at what the problem is, everything surrounding the problem, the maintainers who would be dealing directly with this problem and who would be affected by our solution. So during our visit there, we were able to get a look at this component while I was on the aircraft, and we were able to see that when the RMA is removed from the aircraft, it's done for a couple of reasons, maintenance being one. It reaches certain cycles and it needs to get taken off for repairs or checks. So when that happens, in order to knot down the aircraft, they ship a new one in, and they take the old one off and they replace them and keep going. But there's a slight flaw in this process where when the new one comes in, it's in its shipping container. And when they have to pull the old one off, there's nowhere to put the old one. So they do the best they can. They put it at the best place in the hangar, and they replace them. So the problem really being was that this old RMA that needed to get repaired had no place to go and wasn't being protected or in a good, safe spot, so that it wouldn't get damaged or corroded or anything. So with that understanding, we were able to really dig into this problem and better evaluate than if we didn't go down there and talk to the people who were using it. So we were able to get a list of functions from the maintainers as well as the engineers that would be like the haves and necessities for our solution. Some important ones was that they really emphasized that they wanted it to be simple and user-friendly. They wanted it to be easy to use. They didn't want anything super complicated and, just user-friendly. Along with that, down here at the bottom, you can see be O&I level manufactured and supported with government supply. So for those of you who don't know, the FRC has 3 levels of maintenance: the depot, the intermediate, and the organizational level. The depot is what we have over here on Cherry Point. They are the high-skilled artisans, and they do the high-level maintenance when they take an aircraft apart and they do all their maintenance on it. The organizational and intermediate levels are located at the squadron in New River, and they do the basic maintenance on some aircraft parts, but nothing really intense. So this was really the gem of the project, because we had to not only make it simple and easy to use, but simple and easy to make, so that they could make it at any squadron that housed these 53s. So from there, we were able to make what we call a need statement. And that need statement is to engineer and design a solution that can be O&I level manufactured to hold, store, and protect a removed RMA from the CH-53K for up to 28 days. And that 28 days has to do with the preservation procedures to prevent corroding or rust out or anything down there in New River. From all of this evaluation that our teams went through, we were able to come up with requirements, as Savannah mentioned earlier. And this list of 18 requirements is what our team brought to the engineers and got approved on to move forward with designing to these specifications. So after this process, we then moved into concept design, as Savannah mentioned in the engineering process earlier. And from there, we broke off into 2 teams of 5, and we both approached this project from 2 different aspects, as you'll see. So here you can see an overview of each design, and we're going to have some demos for you real quick up front. And then we're going to go into a brief explanation of how we got from start to finish of each kind of orientation of the design up until now. So you can see on the big screen here, team 1 is going to go first. So when the RMA is lifted off the aircraft, it is brought over to our cart, or the cart to the RMA. It is then set in to these front cups over here. And then once it is seated there while still on the sling, it is then bolted in the back, and the sling is then released. And on the front, on this front support, this front shaft here, there is a strap. It's not shown on the prototype, but we'll show you in the design later. And that's how our design holds and supports the RMA. Team 2.
Thank you. So similar to what the first group was saying, the RMA gets removed from the helicopter via the use of an overhead crane and a sling. They then lower the RMA onto our device and rest it on the black supports that you can see on the screen. A collar mechanism will go over that input shaft and be secured. And then on the back side of our device, we will fasten the RMA to those supports. All right. And feel free at the end to come up and take a closer look at these as well. But now I'm going to turn it over to Team 1 to step through their design process.
All right, thank you, Savannah. Again, my name is Luke Clark, and I'm going to step you through Team 1's design and our design process for this project. So like Thane and Savannah talked about, we analyzed the problem, we defined some requirements, and then our next step was to brainstorm a solution. So each person on the team brainstormed the problem, looking at those requirements, and we came up with 3 basic concepts, as you can see on the screen. We had a suspended style, a cage stand style that could be applied to the RMA and then set down, or like a basic platform or cart. So initially we went with the suspended style design, and we chose this because we wanted something that was easy and quick to use, something that was very accessible to the maintainers so that they could still access the RMA, and something with simple interfaces between the RMA and our solution. So with this, we moved into the concept design phase where we brought this cart design to our customers and we presented this at the concept design review. So like I mentioned, we wanted to have a simple interface. So our idea was to create an adapter that would go between the sling and the RMA, and that adapter is shown in pink. That adapter would then be connected to a support beam, which would then be connected to our cart. So we received approval at the concept design phase, and we continued on into the preliminary design phase. And at this point, we added an additional frame layer to our cart, and we also added an additional mode of mobility. As we continued on with this design, we started to find some complications with the suspended style. So we decided to drop that idea, pun intended, and we moved to this cart that you see on the right. So with this cart, we moved into the final design stage, and we got to the final solution, which you see on the table and on the screen. So what I want to do is just talk through some of the features of this cart and why we chose it. So we wanted to have something that really protected the RMA. That was the main point of the project, was to protect the RMA while it was off the aircraft. So what we have is this frame that will basically surround the lower part of the RMA and protect it. And then that frame is attached to the bottom frame by these black things that you see, which are shock isolators. And so what those do is they relieve any sort of vibratory or shock load that our cart may experience while it's being used. And we had to put a lot of design and analysis into those to make sure we had the right sized and right type shock isolators. The next thing I want to point out is the fork pockets at the bottom. So these enable our cart to be picked up by a forklift and moved a longer distance that you wouldn't want to push with just the handle and the caster wheels. Next up, you see the flanges that Thane pointed out in our demonstration. Those bolt onto the RMA in the same way that the RMA is bolted onto the aircraft. The other supports we have are these cup supports and the strap, which support and secure the RMA on the other side. So another part of our engineering process was the analysis that we had to put into the cart. So what we did is we started by thinking about what sort of things could our cart experience while it's being used. So it could hit a pothole, it could hit a bump while it's being pushed. It could have a front or a side impact, whether that be our cart hitting something or something else hitting our cart. We thought about our cart on the forklift and whether those beams on the bottom are strong enough. We looked at what it would take to tip our cart over in motion or just standing. And so once we identified these cases, we started to analyze them. And we didn't have time to analyze all of them, but even with just the few that we chose, we had quite a few calculations to go through. So this is what we presented to the engineers at the critical design phase. And this was about half the calculations we did. These were like the critical cases. So that's what we did we're not going to go into the details of these, but this is what we did to analyze our cart and make sure it was strong enough to hold the RMA and protect it from forces. So now this is just a brief cost overview. So we have labor and cost that we estimated. We estimated that for one person to build this cart, it would take them about 12.5 days, start to finish, which would be about $5,000. And then we estimated that the material cost would be about $4,200 for a total cost of $9,200. This next part may or may not surprise you, but we also estimated that our total time for 5 people over the year that we worked on this was 1,600 hours for a total of $240,000. But we're in a promotional period right now. Student discount. It's going to be $0, one time only. So with that, I'm going to let Team 2 go over their design. And please take note of any questions you have. We will answer those at the end.
Thank you, Luke. As he said, I'm going to go through the same exact process that Team 1 just did, but for Team 2, obviously. So starting off, we started off in the same brainstorming stage. We looked at a basic supported frame concept, the same suspended frame that they mentioned as well. and also a modular 3D printed concept. So remember this because we end up circling back around to this, but initially we decided to go with the bottom supported frame. It seems simple to make, simple to use. So that's where we wanted to go with initially. So arriving at our first design review with the engineers, this is what we presented. This is a welded frame with these aluminum supports that you see sticking up. We use shock absorbent casters in order to mitigate any of those vibrations that Luke mentioned before. Additionally, we had these quick release pins in each of the corners that allowed our cart to become very compact. So here you can start to see the idea behind Team 2's concept, which is efficiency. We really wanted it to be easy to use, easy to make, and it's not going to be in the way when it's not being used. So we really wanted to emphasize the simplicity here from the very beginning. And as we moved on, we wanted to continue this idea. Like I said, we wanted to reduce the complexity. We wanted to reduce the labor hours. We don't want these Marines having to spend more time building our cart than they are doing the actual maintenance on the items. We also want to reduce the overall footprint. So we want this to be small, efficient, cost-effective, et cetera. So moving forward, the way we did that, like I said before, is we actually revisited the idea of using 3D printed structure, which may sound crazy. The idea of using plastic to support something that is upwards of 400 pounds, which is how much this would weigh at full scale. What we needed to do in order to validate if this was even possible or not was, for one, we needed to determine, is it possible for each of these sites around the world to print this at all? And we figured that out by discovery of the Stratasys F900. This is an industrial-sized 3D printer, and there is, in fact, at least one located at every single site around the world. The next thing we need to determine is there a material out there strong enough to support the 400 pounds that I just mentioned? And that is where we made our second critical discovery, which is Ultim 9085. This is a FAA-approved, government-approved thermoplastic that is incredibly strong. So now that we knew they can print these logistically, they have a material that's capable in theory. So as we move forward, we looked in any way possible that we could transfer anything that had to be welded, bolted, et cetera, to a 3D printed part. So what can we streamline with this design to make it basically printable? So at the end of the day, the dream was to hit a button, and when it's done, your design is done. It doesn't require much labor. So this is where we arrived at our preliminary design. First thing you might notice is we have a purchased cart. So we opted out of welding an entire frame together or 3D printing an entire frame, as both would be counterintuitive to the idea of trying to 3D print as much of the structure as possible. So we go with a purchased cart here with the same pneumatic tires. We have the 3D printed supported material, which you can see in red. We have a gear rotation lock here in green. We have the forklift interfaces that the other team mentioned as well underneath the cart. And then we have the securing collar in pink, which we showed you up here on the top of the prototype, securing the top of the shaft. So as we moved towards our final design, there were really a few things we needed to polish up and change as we move forward, figuring out what's strong enough, what isn't. One of them being the collar that you can see at the top there in pink. We wrapped it all the way around the side so that you could properly bolt it into the structure. The other being the gear rotation lock that I briefly mentioned. So we determined that the weight of the RMA itself actually mitigates the need for this. So we figured out even more ways to simplify the design. There was no need for this, so we removed it entirely. Another change being the base of the 3D printed structure. So we redesigned this in order to make it easier to use. So you can see those little bolt holes, very small on the presentation. We moved those out to the edge of the cart. So once again, we're thinking about how easy this thing is going to be to use. You don't want to reach all the way underneath the middle of the cart just to turn a little bolt. That'd be a nightmare. So just through the whole process, we're just thinking about how we can make it easy to use, how we can make it easy to make. Here are the forklift pockets. You can see they changed shape. We wanted to do this, once again, we wanted to accommodate for all the different types of forklifts. We want every site around the world to be able to use this seamlessly. And here you can see our final design. So the last thing you might notice on this slide is that the one on the right does not have a cart at all. The reason for this being that we identified the instance that they cannot get this purchase cart, it's either in backlog, they can't get it, whatever, it's damaged. We also analyzed our system and determined that it can be used without the cart. So realistically, if you have the bolts you need, you can hit print on the 3D printer. And when the print is done, you will be able to take the RMA off, set it on there and walk away, which was really the dream from the beginning of the project for Team 2. So the same way that the Team 1 did, we had to make sure that this was actually going to hold it, that this isn't just a dream, that plastic can actually do something like this. So we identified the same possible load cases that they did. So what can happen to our cart when it's being used, when it's being loaded, when it's being whatever can happen out there. So we then narrowed it down to some of the more critical load cases. And then we analyzed a few of those for the scope of the project, front impact, top impact, and what happens if this thing tries to tip over, someone's leaning on it, et cetera. So here you can see the calculations that Team 2 presented to the engineers at our critical design phase. We actually are going to start going through all of these right now. No, just kidding. But yeah, it took a lot of math, especially when in the back of your head, you're thinking about big plastic pieces holding something very, very heavy. But moving on, looking at the final design cost for our team, we determined that the total labor time would only be around 2.5 days at $2,250. This is coming from the fact that you still need to add these forklift pockets on the bottom of the design to the bottom of the cart. But the majority of your manufacturing is coming from the bed of the 3D printer, which takes a print time of about 7 days and $17,500. As very special materials, comes with very special price. And then we also estimated an engineering hours working on this project of about 1,600 hours, or $250,000 in engineering cost. So with that being said, I was going to invite my other presenters up here to receive a few questions. Do we have any initial questions?
We got one on the right.
So you said that one of the goals was to protect against corrosion. So how did either of these designs address the corrosion protection issue?
So as we worked through a lot of those different stages, a big part of it was continuously going back to the fleet and really figuring out what exactly they really needed. So the corrosion resistance was something that was brought to us initially. That's something that they thought, like, we should probably get this. Like, we need to cover this thing up and protect it. But as we worked further and further through the project, we really found out this thing needs to come off and they need it to be sitting and safe relatively inside the hangar. So we really worked through the requirements and kept ironing them out. And we figured out what was necessary and what wasn't necessary in the end.
Thank you.
We got 2 hands over here.
Safety being the first concern for somebody on the receiving end of the RMA. I'm looking at Team 1's design and seeing the cage that's put around it to protect the RMA. Is that installed after the RMA is secured? Or is that the way that it is designed initially to be when the RMA is dropped down from the dangling cable? And I've got my hands in there to try to hold it.
Yeah, so I think, like you said, second, it is one solid piece. So the RMA does, like we did in the demo, the RMA is lowered into the cart here. And ideally, the maintainers are not going to have their hands, in the pinch points. So they'll lower it down very slowly. And then once it's in position, once it's resting on the cups on the front and secure, not moving anymore, then they would apply the bolts into the back. And then they would fasten on the front. So yes, there could be some concern with lowering it in. To answer your question, the shipping container that they send is the same process for putting it in and out of the container. So they should already know a good, safe procedure for doing something like that. But that's a very good question. Thank you, sir.
Yeah, that's one of the reasons, they look the same. They both have a taller support and then a shorter support and then two brackets that bolt in. So that whole concept was really derived from the original procedures that they already are taught to follow when removing this. So really, the idea is that we have two quicker, more accessible solutions that already follow the same procedures that they know how to do.
They had zero injuries on those previous procedures.
I am not sure about that.
The only concerns that they explicitly told us was that the original shipping containers, they had some tolerancing issues. So some containers it wanted to fit in, some containers it didn't. We didn't get into specifically how we mitigated that issue between the two teams, but both teams figured out how to make sure that we don't have tolerancing issues. It should, no matter which RMA, around which site, they should all go in pretty seamlessly into the containers that we created.
And we had a question on the back, I believe.
Congratulations to both teams. It's a great designs. I really like your forklift access points. I think that makes a lot of sense. I also was thinking about human safety factors. What was your approach to addressing the balance of the weight on your carts so that human safety is taken into account?
Sure, we can go with ours. So we calculated, if, I'll turn this cart here. The center of gravity of this component, we didn't have the exact location of it, but we did have the sling going on there and it lifts up straight. So we assumed a center of gravity of this component and we located that and the location of the outer wheels appropriately so that you would have to push this cart substantially before it's going to tip over. Does that answer your question or was there another aspect? Did you all want to talk about that as well?
Yeah, so one of the aspects that I didn't speak about when we redesigned the red base that you see there, so that it perfectly lines up with the edges of the cart. So that is so they literally can't install it incorrectly on the cart. What that did was ensure that our center of gravity, basically where the weight is acting directly down the middle of the cart, will always be right in the middle. So that we know exactly how much force every single time that it would take to tip over. And like Luke said, we determined very high values for these safe values.
Did we have another question on the back row?
Yeah, so I had a very similar question, in that obviously it's a very odd shape. So how did you determine what the proper support points were?
That's a great question. Thane, do you want to answer that?
Yeah, so it was interesting because as you saw, team one wanted to do a hanging style first, but unfortunately, because this aircraft is newer, we were unable to obtain a lot of information because we were unable to obtain the drawings for it. So a lot of this was, okay, there we go, sorry. A lot of this was us having to do everything we could with the drawings we were provided. So, I'm sorry, what was your question? That totally killed my train of thought.
You center of gravity with that. Well, why did we use these four supports? Yeah, right.
Dude, these things, okay. So that's,
You're good.
okay. So we use these four supports because I think Andrew mentioned earlier, the current shipping container that they ship the new and the old ones back and forth with use these mount points. So they use the two front supports here for the input and output shafts, and they use the two flanges. And the flanges are also how it's connected on the aircraft. So we proved that the materials we chose could hold it, but we knew that the RMA itself would be okay because that's how it's currently supported in other orientations. Does that answer your question?
Thank you.
Thank you.
Any consideration on the 3D printed material as to its susceptibility to other hydraulic fluids, gas, those kinds of things?
Yeah, it's already approved for, Boeing actually flies these on a couple aircraft. Not that that means a lot right now in the news, but this is FAA approved. It's EASA approved. So that's the European Aviation Safety Association. It's gone through rigorous testing. It's specifically a thermoplastic designed to operate in the aerospace industry. It is approved for toxicity ratings, flame, corrosion, basically anything you can imagine that it's going to stand it, as well as UV. So it's really a special material, it's why it's so expensive. But yeah, it can withstand pretty much anything you can throw at it unless your goal is to destroy the material.
And each one of those will fit in the printer.
Yeah, the printer can print 3 feet by 3 feet by 2 feet. So we would print the tall support section and then the shorter support section in 2 different pieces. You can do them simultaneously because each site has more than one printer from what we've determined.
Question on the back?
Did you look at how these would operate aboard ship? Like decks that are very rough or smooth, but pad eyes all over, and I know you put some shock absorbing things in there, but did you account for that sort of a surface?
Yeah, that was one of the reasons we chose the pneumatic casters, is so that it could go over some terrain. And then we also put on, if you can see toward the bottom part of the cart, we have shackles there. And those would allow our cart to be tied down onto a ship deck. Question in the back?
So you stated in the beginning that you received a new RMA in the shipping containers. Was there no thought process, just put the old one back in there, or can you help me through the thought process on that?
Yeah, so that was our original solution to the problem as well. Just put it in there and put it back. So these shipping containers go into the government supply system. It's a long process, but basically it all boils down to they can't use those shipping containers. They go back into a supply system to be used as a shipping container. They can't request them. If they did and they got one, best case scenario, a couple weeks, which is where we kind of stepped in. We needed like a quick, interim, cheap, simple solution that they could use to put this on. So long story short, they can't use the container. So yeah.
One other thing is cannibalizations, so there's no shipping container.
Correct. What he just said is there may be a case where they're not getting another RMA in a container. And so this RMA would be coming off an aircraft and there's not going to be a container. So it's got to go on there.
So team 1 has shock absorber built into the frame itself, and making the assumption that it's using a forklift to move it from point A to point B. For team 2, how do you address that issue where there is no shock absorbers built into the frame, where it's only on the wheels?
So as we moved through the detailed, when we started considering vibrations and the detailed analysis, we started with the presumption that most support equipment out there has as well, which is their only primary form of vibration mitigation is actually the pneumatic casters. Apart from rubber that is in between where the part actually interfaces with the cart. So I didn't touch on it because the name, but we use a Viton fluoroelastomer rubber compound that sits in between every spot where the RMA rests on our structure. So that also helps to dampen some of the loads it might experience while it is off the ground, so the wheels aren't doing anything. You're right. And then additionally, the plastic material itself has a lot better vibration dissipation than like a steel structure or aluminum structure would as well.
That was one of the things that we were definitely friends and enemies. And so we did have a bit of a competitive nature. And you can kind of see we went for more of a structured, more protective cart, and they went for a more easily manufacturable, quicker to make sort of solution. And I think both have pros and cons. And I think you pointed one out, is we wanted to give them some shock absorption if they've got it on the forklift and they've got their casters in the case of pushing it around. But like you said, on the forklift, it's not there.
Definitely trade-offs between the two ideas, yeah.
In the back?
So are these intended to be shipping containers as well, or are they just temporary storage and mobilization carts?
These are just local mobility and storage carts. Oh, we got two. I'll go over here first.
So for team 2, did you guys find that the strength of the ULTEM was such that it was fine for the clamping loads when you're securing it to the base, or did you have to consider like inserts or
that kind of thing.
Yeah, so we did the calculations based on bolting straight through the plastic like that. And yeah, in compressive, it's incredible. What the material is capable of. Was there a specific load case you were
No,
actually,
just-
just the clamping, the compressive force?
Was curious whether you had to, consider oversized for an insert to go in there or something, or if it's good.
No, I mean, we talked about it, but I think as far as we did the calculations, we had high safety factors, bolting straight through it, shear, compressibility, everything. So, as far as the design is, as you see it, there's no inserts. No.
Did you have to calculate it against different fill forms, or did you just go with solid?
Oh, you're talking about infill? So yeah, we considered, so 3D printing takes a long time. So we explored different infill percentages, which is basically the inside of the volume of the structure, how much of it is actually 3D printed and how much is just empty space inside there. So it gets really difficult to actually calculate what a structure can withstand when it's partially infilled. It requires a lot of computer software. So for this project, the inside is 100% infill. But if you did have an expert team in finite element analysis, they could look and optimize this and drive your price lower, your print time lower, et cetera, by making the inside a lot less plastic and more air actually. But everything here is, we calculated at 100% infill.
When the customer brought you guys a problem, did they know what they wanted or what the problem was, or how did you guys kind of dig down to that answer to find the solution?
So, I believe you were the customer. So great question. Yeah, like I talked about earlier, we wanted to get all perspectives. So you guys as the FST, we had your engineering perspective. I believe you guys brought us to us like maybe, like was mentioned over here, maybe the shipping container is the answer. And so looking into that more, we realized it's not always there, as was mentioned. And then when we went down to New River, we talking with the maintainers, they were like, we don't want a shipping container. We don't need a shipping container. They're like, I believe they told us if it was as complex as a shipping container, we failed. And so they're like, we just want to stand in something that protect it. And, the protection requirements came from you guys, the engineers, so.
And that's a good point too, as well. And that's something that I appreciate this program for, is Dr. Fortney really expressing to us that, to dig deep into the problem and to not always just agree with what the customer says. You want to truly meet their needs. So that requires some further research.
Background.
So what was the plan or at least the discussion about validation of the design meeting, say, strength requirements? Is there testing that was considered that would be part of this design process?
That was not part of the scope of our project. We were just to do the analysis and then provide the report of what analysis we did. And then if they wanted to build it and validate it, they would have to do that on their own. Good question.
But normally, yes.
Yeah.
Did you guys have an opportunity to actually show your designs to the folks that are physically doing this?
We have not been able to do that now.
Back row?
Would be made if it's accepted.
I think the ideal situation is that if they need one, they can just make it on the spot. So if they hear that something's going to be coming off this week, maybe by the time it's off, they already have a solution materialized within the facility itself. They never had to reach out. They just initiated the work order and then bam, it just comes right off onto the cart that they made themselves. So I mean, on demand.
That 5 locations, 50 locations, like if you made them everywhere. So I'm just curious the number.
Scale. I don't know an exact scale. Do you know how many sites?
Well, there's just one site.
New River, just one site currently at New River.
This was a 53E.
Yeah.
If it was,
Yeah.
we're looking, as far as permanent sites, you got New River, Miramar, Okinawa, Norfolk, and Byron. Potentially the TMI sites as well. So,
Yeah. So later in the aircraft's life, whenever it expands to all the other sites, it'll definitely be a lot more of these being made theoretically.
Do all of the potential sites have the 3D printing capability and capacity to spend 7 days when they need it?
Yeah, from what I talked to the guys at our local innovation lab at FRC East, and from what I was told, and we got to see a couple of them firsthand. I think New River, I saw 4 of them there. It seemed like each squadron at least had one. I'm not sure if every single squadron, but a lot of the sites, yeah.
Another in the back there.
You guys are doing a great job. I don't think I've ever seen this many questions.
Is that your boss?
That's my boss.
But just because we only get to mentor you for a little bit longer, what Marissa touched on is super important, right? If you have a concept at concept time, and I know you guys were constrained in your ability to communicate with the end users, but I know in our environment, going out to the shop, to the guys that are going to build some things, guys that are going to use the thing, or girls, and just communicating your concept with them, that's going to make you a lot better engineer in terms of being useful to the end user, right? So don't ever forget that part. Obviously, you couldn't do it. You were limited in your ability to do it this time, but as soon as you have a picture you can put on a piece of paper, bring it out and talk to somebody about it. If you're needing to solve somebody's problem that's going to be hands-on with it, if you have that opportunity, take advantage of it.
Yeah. So I don't think it was iterated quite enough. We did go 2 or 3 times down to New River. And I remember, I think one of the later times I had my iPad with all of my hand sketches on it. And I was up on the aircraft talking to the guy, showing him if it made sense. And so we did go through it with him a little bit visually. But into the later and later stage of the project, it was crunch. It was definitely crunch, yeah.
Come up with stuff that you never even thought of.
Yep.
You feel like a real idiot for not thinking of, but they'll really help you out.
Yeah.
Thank you.
For your PPE when you were up on the air.
Every single time.
Yeah, so what is the lowest level maintainer that could typically build one of these? I don't know if it was discussed in the final presentation between the 2 designs.
That can build one or operate.
They have the instructions to build one of these standard 2, so OI, what's the depot level, what's the lowest level that can take these procedures and build them?
I mean, we were really designing them to the guys that we were speaking to directly in the shop. They referred to themselves as O&I level maintainers and manufacturing facility. I know they talked to the weld guys down in the weld shop at New River. I spoke a little bit with the 3D printer. He said he could do it. So the guys that work already in those areas, they said that they would be capable of making them. So that's really what we were designing to. I don't know about someone coming in and trying it for the first time. But yeah, that's who we were designing off of.
So essentially the end user of this would be.
Yeah.
Any more questions?
Plenty.
One more in the back.
Actually have a non-project question, if that's okay. Where's everyone headed after graduation?
That's a
Across the
great
street.
question. I guess we can let everyone say if you all want to stand up and we can just go down the line and tell where we're working after. Thane, do you want to start and then we'll go down that way?
I currently am an intern on the H1 FST for structures. So I'll start there full time on the 20th of May.
I am currently interning at Tandem Lock Incorporated just down the street, and I'll be starting at the Nibay as well.
I have been interning with H53 Drives with my boss back there. So yeah, I would just be continuing full time on May 20th there.
I will be starting on May 19th as a full-time engineer working with the MQ9 support equipment team, my lovely team down there.
I'm going to be over on FRC. I think I'm still going to be on the H53 team that I was with interning last summer.
I'm the oddball in the group. I'm going to be moving up to Ohio. I'll be working with the company Elwood Specialty.
Why are you moving to Ohio?
My fiance lives up there. And we're getting married in just over 3 weeks. So I'll be starting my job.
So I currently intern at Tandem Lock, and I'm gonna go full time in May.
I'm currently interning with the H53 program on Trade Point as well. I'll be working there full time in June.
I've been interning with the H53 Drives team like Andrew with Troy
Been full-time throughout school and I'm just gonna continue full-time after this. It's been full-time.
All right, is that gonna wrap us up for the questions?
Any other questions, comments, either way? Anything y'all would like to address to the group?
And we would love to talk with you after. We're going to be up here, so we'd love to answer any questions you have for us personally. And we just like to talk about our project. Just no hard questions. If you could hit the next slide here. We did want to just extend our gratitude to a few different organizations here. So first of all, NAVAIR and FRC East. Our customer was great. They gave us good feedback. They were very receptive to us. So we can't do this without a good project. So thank you all. Next up, we wanted to thank the Marine Corps Air Station in Jacksonville. They were very welcoming to us. We were able to go down there several times, like they mentioned, and get a lot of good information. The Marines there and everybody we encountered was great. Then we also wanted to thank the faculty here at the NC State program in Havelock, Dr. Fortney and Dr. Dave, who wasn't able to be here today, unfortunately. They were great instructors for this entire year. We want to thank Michelle as our great advisor and Miss Susan. And then last of all, we just wanted to thank you all for coming out, spending a little bit of time of your day to listen to us. And thank you for investing in the program and in us as students. So with that, thank you all. Have a great day.